All right. Okay. Yeah. Hello, everybody. My name is Minko Gechev, and I'm currently one of the leads of Angular Developer Relations. Today in this presentation, I would want to share with you what is the current state of Angular. This is going to be also kind of a theoretical discussion as well. We will be talking about the reasoning for some of the decisions that we have been making in Angular for a while actually, which could be considered quite different from where the rest of the ecosystem is. For example, we have been focused a lot on some static optimizations and static typing, like TypeScript, and many other such features, which are bringing some specific benefits when it comes down to development of Angular applications. Since I don't know how familiar you're all with Angular, I want to give you a very high-level overview on what we have been building actually in our team. Of course, we have a framework, right? We have Angular Core. It provides you with a bunch of primitives that allow you to compose complicated user interfaces. You pretty much have here components which can receive certain inputs, and they can also emit outputs. And on top of that, when you decide that your source code wants to be more testable, you can take advantage of the Angular dependency injection that comes together with Angular framework. We also have advanced content projection and many other features, but in order to get started with Angular, all you need to understand is just the component model, how you can create a component and how you can compose components together. On top of that, if you have been using the framework, you probably know that we have a pretty powerful CLI. It actually has pretty wide adoption, not only inside of Angular, but also in other frameworks out there as well. Together with the CLI, we're building components, the Angular material implementation, as well as the Angular CDK. All of them help you to quickly bootstrap your application. Of course, we cannot provide all the different components out there that exist. You can take advantage of them from community projects, but we provide a pretty solid core that allow you to quickly bootstrap your application and know that these components work pretty well with the framework since they're developed by the same team. On top of that, we provide internationalization. This is actually a module and a mechanism, in fact, that I would want us to discuss a bit further in this presentation, because this is probably a pretty unusual implementation of internationalization compared to like all other implementations that you might have been used to in other frameworks. So I would really want to spend some time discussing some of the reasoning of us behind it. This is going to be somewhere around the end of the presentation. We also have a language service, a router, animations, forms, and much more. And these are all maintained by the Angular team. So we have this right now. And to get here, well, it was a pretty long journey. I was lucky enough to be able to follow this journey, especially for Angular, since pretty much the beginning, when I wrote my first Angular book. And it was pretty exciting for me to observe this from the perspective of a third-party contributor, just contributing to a popular Google project. Now, later on, when I joined the team, I see how things are moving pretty fast. There are different requirements coming from the evolution of the web, coming from Angular engineers, and in general, coming from the requirements of the business so that we can efficiently ship new features of business applications, right? That's our goal at the end. So the Angular framework itself, it went through very different paths to be where it is today. I'm pretty happy and confident to share that right now we're primarily focused on stability, making sure that we're addressing the issues that we have been collecting on GitHub recently. We have quite a few of them to take care of. We're also investing a lot in simplicity. As you can see, we're constantly trying to reduce the conceptual overheads of folks who are getting started with the framework. And also, as usually, we're focused on speed. We want to provide the best and fastest change detection out there. We want to make sure that we enable best practices such as component level code splitting, route level code splitting, efficient prefetching, and so much more. Of course, at the same time, we have opened the space for innovation. This doesn't mean that Angular is now a mature project that is not going to grow from now on. Of course, it is going to grow. I'm going to talk particularly about this and how we're going to communicate our roadmap with community a little bit later in this presentation. So currently we have over 2,000 projects inside of Google. To be exact, I believe the number is above 2,600. So for the past about 10 months, we got 600 new Google projects developed with Angular. And the current version of the framework is version 10. I'm going to talk about some of the features that version 10 introduced, but before that, let us discuss the theory behind the framework. I have mentioned this many times in many different presentations, but I'm really excited about compilers in general. I have this kind of academic interests in compilers and programming languages, so I really like to talk about the theoretical foundations, which are actually inspired to a big extent by the compiler design, which we made in Angular. Often I prefer to start talking about these theoretical foundations in a very practical context. You're probably all familiar with the trade-off of predictability versus flexibility. A good example is the daily schedule of someone. Imagine you have a very booked calendar where you have optimized your schedule up to a minute. You know exactly when you're going to wake up. You know exactly when you're going to prepare your coffee and take it. You know exactly when you're going for a workout, going to the office, and so on and so forth. The schedule could be a little bit stressful for a human. Of course, for a computer, this doesn't really matter. If you utilize the resources well, the computer is not going to be stressed out by having a really well optimized and strict schedule. But for a human, it could, and both for humans and for computers, it could be really hard to introduce something new into the schedule, right? It's going to be really hard to introduce a new task since everything is already pre-booked. Your calendar is completely full. So you're very productive, but at the same time, not too flexible. Compared to flexibility, you can have your calendar completely empty. You might not be like doing absolutely anything, and you could be potentially like improvising every next day with what your schedule is going to look like. And this way, you're very flexible, but potentially not too efficient. In the context of programming languages and frameworks, this trade-off is better known as static versus dynamic. Static usually refers to operations that are performed ahead of time, at build time, during compilation. And dynamic are resources or like tasks that are performed like just in time, in the browser, at runtime. We can put some programming languages on this axis so that we can give you a better like intuition on what static versus dynamic means. My guess is that you're familiar with some of these programming languages, for example, with Rust. Rust is a pretty popular programming language coming from Mozilla right now. It has a really powerful, but at the same time, really static and really strict type system, which doesn't allow us to do much. So if we don't follow the constraints set by the compiler, we will not be able to run our program at all because, well, it is not going to compile. But at the same time, this static behavior and strictness, it is helping for a very efficient memory management. On the other side of the spectrum, we have JavaScript. And JavaScript is a super dynamic language. With JavaScript, we don't really have to fight any compiler because we actually have zero compile time. But at the same time, we don't have any guarantees that our program is even going to run in the browser. We get some runtime errors, and if our program starts growing, we don't know if we're going to catch these runtime errors before shipping our program to production, right? So it could get quite tricky. We're sacrificing in this case like stability and static verification and knowing that our program is going to work in general in the browser for better and faster prototyping with JavaScript. TypeScript is somewhere in the middle. So with TypeScript, we have a good type system, which can help us prevent a lot of issues ahead of time. But at the same time, it is not constraining us much. It is not restricting us too much to be expressive and to be able to rapidly prototype new features. So I would say that TypeScript is really well positioned into this spectrum from like static to dynamic. Of course, this still depends on the purpose of the language. I'm not saying that TypeScript is better than Rust. It very highly depends on the use case that you have. For example, with Rust, you can build really efficient and low-level systems, which you cannot build with TypeScript nowadays. It is also very interesting that from static, you can very easily go to dynamic. Imagine we have a very statically well-typed TypeScript program. We have very explicit type annotations, and well, we're pretty confident that our program is going to run and is going to work properly at runtime. Well, it's going to be very easy to make it more dynamic. It's going to be very easy to just drop some of these type annotations and get rid of the constraints coming from the compiler, and be able to start prototyping more like faster, just by introducing new expressions with type any or so on and so forth. But starting with a very dynamic program with a JavaScript program, which has never been type checked before, it could be pretty tricky to make it static and to add TypeScript type annotations. Not that it is impossible, it is just going to cost us a lot of work. If we put some like more tangible features and associate them with static and dynamic, we can think about them the following way. For example, compile time optimizations is something that static systems can provide. You might have noticed this in Angular. We have these static HTML templates, which are in fact translated to JavaScript. And they're translatable to JavaScript because they're static and the compiler understands them ahead of time without we having to execute the source code in the browser. So we can statically analyze the templates and very efficiently translate them to JavaScript instructions and make them really fast for execution. Angular, in fact, has been innovating a lot in this space in the past. If you're looking at the framework landscape, you can notice that Angular was probably the first framework to introduce ahead-of-time compilation. And you can see that this is now a common practice. And a lot of different folks found out that this is a quite powerful concept, right? Also, static systems allow us to have much better text editor and IDE support. You can, again, compare TypeScript versus JavaScript. The TypeScript types annotations provide much more context to text editors and IDEs so that we can get good auto-completion. Strict type checking is something that I'm going to discuss just in a little bit so that I can give you kind of a tangible idea for the results that we're getting out of it. But on the other side, dynamic systems are not bad as well. Dynamic systems can allow us to perform very dynamic behavior. For example, we can even dynamically assemble the user interface. And the huge advantage of dynamic systems is that we don't have a build process there. So you can just put a bunch of scripts in the browser and everything is going to work. You don't really need to go through some kind of a build process that transforms your application to something else. So something that's just a conclusion that I reached out several years ago, and I'm sure that I'm not the first person who have reached out to this conclusion, is that it's much better to get your errors ahead of time during your build process instead of getting them at runtime when you have deployed your application and you have shipped it to your users, right? So, of course, the best possible scenario is if we write bug-free programs, right? I wasn't fortunate enough to be able to create a large application without having any issues in it. So if you are capable of doing this, you definitely don't need build systems. But if you're just like me, you probably can benefit from TypeScript's type checking and from static systems. So here is an example which actually points out how beneficial TypeScript could be in your day-to-day development process. And when I'm saying TypeScript, I'm not necessarily meaning only TypeScript, since in Angular we have type checking in templates as well. So a couple of folks from community and from academia and Microsoft, they did a survey. They pretty much looked at different GitHub projects that were developed with JavaScript. They looked at their issue trackers and they tried to just verify which one of these issues was going to be detectable by the TypeScript type system at build time. They found out that 15% of the bugs were going to be detectable at build time instead of runtime. So this means that these issues were never going to exist in the final product. So users would never have to go through the experience of hitting these issues. They would have never went through the experience to reporting them, and developers never had to go through the process of fixing them. Imagine how much time this is going to save in a large organization working on a complicated project. And this survey was done with TypeScript 2.0. So this is TypeScript 2.0. Now we are in TypeScript almost 4.0. It is coming in the next couple of weeks. It has much more powerful type system, and it helps us to catch many more issues ahead of time. So here is an example how static systems could be really powerful. I know that we usually associate dynamic with good, but I just want to show you a different perspective, how static could be helpful in letting you develop more high-quality products. All right, so talking about static and dynamic and putting them into the context of frameworks, AngularJS, this is the framework that Google released in 2009. It is very dynamic. It is on a very dynamic part of the spectrum. You can just take Angular, you can place it on a page, and you can start developing your program. You're not going to get any static verification by the build process. You're not going to get any type checking or whatsoever. But at the same time, you didn't have any build process. So you're able to prototype very quickly, and you didn't have to wait for your production build to complete, right? You're actually even able, if you want to, and if you want to live on the edge, pretty much develop your application in production environment. Why not? Angular version 2, however, started with a couple of things in mind. First thing was that static things and static checks are really useful. They provide better compile time optimizations, so they make the framework faster. They improve the text editor and IDE support, and also allow us to catch many more issues ahead of time. At the same time, the framework team also knew that if they start with a very dynamic framework, they would be really struggling to make it more static, because they're going to break a lot of projects. So what they did back then, when I wasn't part of the team, they just made Angular version 2 really static, really constrained. You weren't able to declare, you had constraints on how you can declare providers, let's say, in your engine modules. You had a lot of different constraints, which were probably not necessary at the beginning, but that was a pretty good shot to make the framework static at first, and from there grow it to a more dynamic solution which provides better development experience. So that's what they did. For version 4, there was a rewrite of the compiler and the view and a rendering pipeline, which made Angular more dynamic. With Ivy, we did one more such rewrite as well. So Ivy was this big project that we worked on for over 2 years, I'll say. This project took us a lot of effort because it was a really large rewrite of the internals of the framework, and you can't imagine what tiny things that you would have never expected can have an impact on existing code bases have. So just like changing tiny internal piece in Angular can break hundreds of people or even thousands of projects. So that's why it took us quite some time to make sure that Angular version 9 with Ivy was completely backward compatible with View Engine, which was our previous compilation and rendering pipeline. So we made Angular more dynamic, but also not too dynamic, so that we cannot take care of all the compile time and static optimizations. Now let me talk to you what is happening in version 10. That was a pretty long, I would say, overview of different trade-offs that we have in software engineering. Now, version 10 is a pretty small release when you look at it. We are pretty much providing an opt-in strict mode, and we're also aiming to increase more the visibility of what we have been building in the team to community. Now, I would want to talk a little bit about the second part. I would want to actually acknowledge the pretty rough feedback that we have been receiving over the past couple of weeks. Some of it was more constructive and reasonable than the other, but we definitely listened. You might have also noticed that we didn't share any public direct response. This doesn't mean that we didn't acknowledge and listen to everything. We have been, in fact, listening for quite some time, and we have had a plan on how we can increase the community engagement and be more open towards what we have been developing at the Angular team. So in the next couple of weeks, we'll be sharing some efforts. For example, we have been working on, actually over the past 3 months or so, on making our roadmap more digestible, not only by us, but also by folks who are outside of the team, outside of Google, so that we can all understand where Angular is heading to. We have been also working on opening some of our engineering processes. We would want to involve more people into the technical decision making around Angular so that you can provide early feedback on design decisions and just help us to shape the future of Angular and in general of web together. Remembering back when I was not part of the team, looking at the design decisions and the design documents for Angular, these were some of my main resources that I was looking at, that I was reading through in order to understand the framework and even understand many other technical areas where I didn't have expertise back then. Looking at the Angular source code and looking at the Angular's design documents, I understood how compilers work. And from there, I got really passionate about them and started building my own programming languages. So I really think that this is opening this design process is going to be not only helpful for everyone to understand where Angular is heading to, but also to grow together, get ideas from one another and develop them. All right, now let us focus on the technical part of things. Now let us talk about Angular strict mode. The strict mode in Angular CLI version 10 is just a flag. It allows you to build applications with stricter configuration. This stricter configuration pretty much enables stricter type checking. So this helps you to catch more issues ahead of time. It enables stricter type checking for Angular templates as well. It makes the ECMAScript 5 support opt-in. This means that if you want to support Internet Explorer and you're in strict mode, you would have to enable this ES5 support. It also makes the CommonJS support opt-in. CommonJS is this module format that was originally developed for the server, for Node.js. And it got some traction for browser packages as well, which I wouldn't say is too reasonable. I'm going to show you an example of a CommonJS module and how it can pretty much ruin your performance completely in a little bit. But if you would want to use CommonJS modules in the strict mode of the Angular CLI, well, you would not be able to unless you opt in into using it. And also with strict mode, we're assuming that your application has reduced side effects. This is pretty much taking advantage of the side effect property in package.json, which Webpack understands and applies more aggressive tree shaking on top of your applications when it finds this property and the setting. So the strict mode is not something that we're going to enable out of nowhere. This is something that is going to stay in the Angular CLI for a bit. We just want to get your feedback. We want to see how strict mode works for everybody. And if people really love it and they see actually noticeable improvements in their day-to-day development processes in terms of fewer issues or faster applications, we would want to just enable it by default for everyone. But if you find out that it is dragging you back, it is making you less productive because you need to fight with different static checks, and you would want to have more dynamic behavior, we're going to just remove it completely from the Angular CLI and preserve the current compilation pipeline. So see, we still have this very interesting trade-off between static. This makes the Angular CLI more static with more compile time checks, and dynamic, where we have fewer such checks and potentially fewer optimizations ahead of time. Now, talking about more and stricter compile time type checking, I'm sure that in your mind you see something like this. A lot of folks, especially people who are just getting started with software engineering, they kind of find out that they fight with both JavaScript and TypeScript. They get different errors, some of them in the browser's console and others in their terminal, and it's hard to understand the benefits of all this. Well, I hope that I give you just a slight hint that TypeScript giving you these errors just means that there is place for improvement in your program so that you can reduce some of the potential issues that can occur at runtime when you ship your application to production. Now, I would want to spend some time talking about CommonJS because this is a pretty interesting problem, and it again shows this trade-off static versus dynamic. Actually over 2 months ago now, yeah, I wrote this blog post about how CommonJS is making your bundles larger. I just wrote this blog post. This is a well-known fact. I didn't discover it, but the findings in this blog post were pretty interesting. You can find it on web.dev/CommonJS larger bundles. Let us look at some examples so that we can understand why CommonJS is in fact making your bundles smaller. Bundles larger. So here we have a JavaScript program. We have a utils.js module, which has a couple of public exports. So here you can see that we have an export of the add function. We're exporting subtract, multiply, divide, and max. It's interesting that we're importing max by Lodash, and we're invoking it here. Just keep that in mind. At the same time, we have an index.js file. And in this index.js file, we're importing only the add function from utils, and we're invoking it. So here, now we can take this program and pass it to Webpack. Webpack is going to produce a single JavaScript file out of these two modules, and this single JavaScript file is going to be highly optimized. Webpack is going to do everything it can to optimize it so that it can be as small as possible to provide faster user experience for our end users. Once Webpack outputs this file, output.js, this file is going to be over 600 kilobytes. See, almost like more than half a megabyte. See the original source code. In the original source code, we just have a couple of functions. These are for sure less than 1 kilobyte, right? And the final bundle is over 600 kilobytes. That was crazy. The first time I saw it, I thought that I did something wrong. So I spent a couple of iterations profiling what Webpack does, looking at the module loading, looking at the Webpack reports, and so on and so forth, until I realized that, well, that's just how things are. Here we're importing max by from Lodash, and since we're importing it with a CommonJS require, it is getting part, like the entire Lodash is getting part of our final bundle because, well, Webpack just cannot optimize CommonJS modules. I'm going to tell you why just in a little bit. Now, when we translate this to ECMAScript modules instead, here, see, we are exporting the add, subtract, multiply, and divide functions as well. We're also exporting max and importing, again, max by from Lodash, yes. Pretty much the same program, but instead of using CommonJS, we're using ECMAScript modules. The output, after we bundle this with Webpack, is going to be this. Pretty small, right? Pretty tiny. And depending on the configuration of the JavaScript optimizer cursor, this 1 plus 2 could be actually folded to 3. So you can get 2 bytes less. This is 40 bytes compared to 625 kilobytes, right? That's a massive difference. So you can see how a single CommonJS module can completely blow up your application size and make it much slower compared to just using ES modules. And the difference is only in this. See, only the utils modules is slightly different on how we are exporting things. And the interesting thing here is that it is again related to this trade-off static versus dynamic. It may not seem that CommonJS is much more dynamic, but look at this. Here we can export a function with a name that we're getting from local storage by touching the element in local storage associated with a random number that we have generated. So this is extremely dynamic. Pretty much Webpack at build time, it has no idea how to understand what is the module name so that it can get rid of the export if we're not using it. This local storage get item information is something that is only available at runtime. So at build time, statically, we have no idea how to optimize it. This is just one example, but I also want to give you one more example, which is related to the Angular's internationalization. I have been hearing a lot of very mixed feedback about internationalization, and a lot of people have been asking for a runtime internationalization, which allows you to swap the language dynamically without refreshing the page. And originally, I thought that we just don't communicate the reasons why we have taken certain decisions on improving the internationalization with static analysis. So let me share why we're doing it right now. By using our internationalization, you would first compile your Angular application to JavaScript. Here, for all your internationalization markers, where we have specified the I18N attribute, we're going to add some specific other markers using our $localize service. Later on, for each one of your translation files, we're going to take your application and apply direct replacements to the source code. So we're going to replace these markers that we introduced with the actual strings associated with the particular translation that you're building your application with. So this means that with like 4 different translation files, you're going to come up with 4 different versions of your application. I want to address a couple of things here, first of all. So there were problems with our internationalization in version 8 and before, where we had to compile your application once for each individual language that you support. And this wasn't ideal for sure. This was taking a lot of time. Now we optimize this. So instead of compiling your application once for each language, now we're compiling it only once, and we're performing replacements depending on the language that you're targeting right now. Replacements are much faster than the original compilation. So that's why the build process now with like 100 different languages is not going to be so much different from the compilation process with one language, right? We're going to produce 100 different versions of your application as well, but we are no longer having to introduce like individual bindings for the different translations that you depend on, since we're going to replace these bindings with strings associated with the corresponding language. This is going to allow us to remove the runtime overhead associated with these bindings, since a binding means that Angular needs to perform checking there. Like Angular needs to verify whether the current value of the binding is different from the previous value, right? So this means that by performing this compile time I18N, we're making your application much faster compared to binding to the individual translations one by one. Also, we're making it much smaller because each binding is a JavaScript instruction. And this JavaScript instruction adds up, especially when your application grows. So you're going to have smaller application and faster at runtime just by performing such static optimizations. And the cost for this is pretty much zero. The cost is that it's going to be impossible in this case to change the language without refreshing the page. And well, to be honest, users are not usually changing from one language to another in a series just so that they can read your content in like all the different languages that you provide. So this is not a very common use case. You're giving up something small in order to add better performance to your application. So this is a way we implement internationalization. It is much different compared to what most other frameworks do right now. I'm not saying that this is not possible to achieve in other frameworks. This is just the decision that we took, and it is a result of the design that we have for Angular. Static templates allow us to perform static optimizations and produce faster applications. All right, that was pretty much everything I actually wanted to share with you today. I really hope that with this overview on static versus dynamic, I was able to point you to some of the motivation behind the technical decisions that we made in Angular. I'm also hoping that I gave you a little bit more visibility on what community processes that we're working on. For example, sharing our roadmap finally and requesting for comment for some of the technical decisions that we're making. If you have any feedback for my talk or for myself or for Angular, feel free to reach out on Twitter. I'm responding there pretty actively. I spend far too much time on Twitter. And I would also really love your feedback on mgv.io/talk about this presentation.